Okay, so this is 2014 Paper 1, Ordinary Level Question 2. I just suggest that you pause this, have a go at the question yourself, and then start up again. And I'll assume you're back. So let's get stuck in here. You got two complex numbers now. For some reason they love using Z with complex numbers, but I have seen them use U, V, W. It doesn't really matter. Just a complex number, the first one they're giving you is 5 minus I. So 5 is the real part, minus I is the imaginary part. Remember now, all numbers are complex, and in a different question on number systems, you need to be familiar with natural numbers, integers, etc. Now, Z2, the second one they're giving you, is 4 plus 3i. And then they'll always tell you, or will usually tell you, that the I squared equals minus 1. And that comes from the fact that I equals the square root of minus 1. And you're squared on both sides. So I squared, square cancels the square root, I squared equals minus 1. So whenever you see I squared in a question, and you will, okay, usually, not this question, but you should swap it for minus 1, okay? Now, this first part, they're just testing your ability to subtract complex numbers, and they may very easily test your addition, subtraction, multiplication, division ability, use of modulus, drawing on the Argand diagram, and solving of a complex quadratic. And that's generally what you'll get in past leaving cert. I'm going to go straight to the answer just to show the problem here. Remember, you're taking away all of Z2. And I've written it out now in two brackets. Don't actually need the first set of brackets, because they're not going to change. It's as if I'm multiplying by 1, so 1 by anything is itself. It's the second bracket here. You have to remember that you're taking away 4 and taking away plus 3i. And minus by a plus is going to change that to a minus here. Very common mistake to just take away 4 and then add the 3i, and obviously your calculation is incorrect. So once I've removed the brackets, okay, I'm going to take away the real parts. Now I've sorted them here, so the real parts are together and the imaginary parts are together. So I've grouped by like term. You'll notice this is not an equation, there's no equal sign. So when I move things around, the signs didn't change because I moved them around on the other side. In essence, I organized them in a way that made the class calculation easier. Now, I wouldn't expect that you need to include that step. I'm doing it, I suppose, for the obviousness of the video. Anyway, so take away the real parts. 5 take away 4 is 1. Minus I minus 3i. I owe you €1. I borrowed 3 more off you. I now owe you €4. Okay, so it's part A, part 1. It's worth 10 marks. Okay, easy money. So part 2 here, now you're asking that these bars mean a few different things, but in this instance, they mean find the modulus, find the distance of the complex number from the origin. Now the modulus formula is given over here. So in this case, it's not straightforward because you have to find out what Z1 take away Z2 is, and Z2 take away Z1 is. Okay, now I've just done Z1 take away Z2. So the answer to that was what? 1 minus 4i. So it's the modulus of 1 minus 4i. Okay, equals, now if I take Z2 take away Z1, so that's going to be the modulus of, let's go straight to the answer. So the modulus of 4 plus 3i take away 5 minus i. Now again, the same issue, you know, watch out for the minus by a minus, changing that to a positive. I'm just going to resolve this by adding the real parts. 4 minus 5 is minus 1, 3i plus i is 4i. And they're saying it's the modulus of 1 minus 4i, the same as the modulus of minus 1 plus 4i. Now, in a complex number, the first number, there's written in this form, a plus bi. The a is 1, the b is the minus 4. Same thing here, a plus bi. The a in this, for this complex number, it's supposed to be an I, is minus 1, the b is plus 4. You see them here, 1 minus 4 from the first complex number, minus 1 plus 4 from the second complex number, and I just sub them in to the modulus formula. Now I'm putting in straightforward, is left-hand side equal to right-hand side, and working my way down. You see here that it's square root of 17 is equal to square root of 17, therefore it's true. Okay, so you always need a statement of success. Now, arguably the statement here mathematically is the statement of success, but in leaving cert they often want the word, or this, verified, whatever way you want to say it. Now, part 3 here, okay, give a reason why z minus w equals w minus z. So, I suppose complex number 2 from 1 is the same thing as 1 from 2. Okay, will always be true for any complex number z and w. A lot of words. Okay, it's one of these things. If you get what they're saying, it's pretty okay. If you don't get what they're saying, it's not okay. But in this case, the complex number is Z1 and Z2, so are images of each other in symmetry through the origin. Now if I could draw that back here, if that's my axes, and it's supposed to be straight, okay, 1 minus 4i is down here, so 1 of the x minus 4i is probably down here, 1 plus 4i is somewhere up here, okay. You see that they're mirror images of each other, and they're the same distance away from the origin due to that fact, okay. So if they're the same distance away from the origin, then they'll be equal. Those two statements will be equal. Okay, and you can say that the absolute value, this is a different reason. The absolute values of z and w are the same, therefore the modulus will always be the same. Remember, it's not saying, it is, I suppose it is saying, the modulus of z minus w is equal to the modulus of w minus z. They could have been very simplistic and said, well, the a and b are the same for both sides. Okay, I'm sure that we got you at least the 2 marks, okay, if not the 5. Now, part B then, so I think we'll have 10, let's see, 5, 5, 5. Okay, so we have another part after this. Find a complex number Z3 such that Z1 is equal to Z2 over Z3. Okay, all that means is your answer to this question, Z2 divided by Z3, is that equal to Z1? Now you're told, you know what Z1 and Z2 are, okay, and you're asked here to find Z3, so it's not as straightforward as you think it is on first glance. Now if I fit it in, okay, which I'll have done here, okay, what I've done here is I've rearranged it. I've moved the Z3 across here, and the same step moves the Z1 across, okay. You could have showed that as 2 different steps, but ultimately Z3 is the same thing as Z2 over Z1. The reason you have to do that is you have Z2 and Z1, but you don't actually have complex number Z3, so you're going to be finding that. Now, they could have asked this question a different way, and given you Z3 and asked you to prove that Z1 equals Z2 over Z3, and just more straightforward. But there's that little extra step that might catch you out. If I put in Z2 and Z1, I have them here, 4 plus 3i is Z2, 5 minus i is Z1. I've got to do division, okay? Now, to divide complex numbers, I have it written up here, you need to multiply top and bottom by the conjugate of the bottom. Now, the conjugate of a complex number is, I suppose, it's a mirror image. For example, back here, this was 1 plus 4i, 1 minus 4i. They're conjugates of each other. So if I gave you, this is 1 plus 4i, and asked you to write down the conjugate of it, okay, you know what the conjugate is, 1 minus 4i, okay. All you need to do, in essence, is change the sign in front of the imaginary term, okay. Going back to the answer here, I've done it here, multiply top by the conjugate of the bottom, multiply the bottom by the conjugate of the bottom. Okay, and there's a lot of work going on here. I've done it in step, in equation. You could have brought it off to a rough part and done it and brought the answer back in. It's all fine, whatever way, as long as you don't make a mistake calculating. Now I've done it out the FOIL method, so I've written out one term, one bracket twice, multiplying the first part of the first term into the second bracket, the second part of the first term into the second bracket. Okay, now that method, if you want to achieve at the Leaving-Cert level, knowing that method is just needs to be second nature. And I see that mistake so common, and it brings people down in so many questions, because obviously they're not doing it right, they're getting the wrong answer. And if you go left to right, 4 times 5 is 20, 4 times I is 4i, 3i times 5 is 15i, 3i times 1 is 3i squared. Now here's you're going to have to remember that I squared equals minus 1. Okay, that's supposed to be a square. Okay, now I'm doing the top part here as well, so I'm the same method. Okay, so 5 times 5 is 25, 5 times 1 is 5i, minus I times 5 is minus 5i, minus I times I is minus I squared. Now you'll notice here that when you multiply a complex number by its conjugate, the i's always disappear. So those i's here go to cancel, and minus I squared is the same thing as minus times minus 1. So I've done that here. It's going to give me to my last step, 25 minus minus is a plus, so 25 plus 1 is 26. Now the top line here, I've kind of ignored that a little bit. It's 20 plus, now the 5i, was the 4i, sorry, plus 15i as to give 19i. Same thing, the I squared here becomes minus 1, so 3 times minus 1 will give you ultimately minus 3. I've came along an intermediate step, so I can't add on to 19, that's going to carry over. 20 plus 3 times minus 1 is the same thing as 20 minus 3, which is 17. Now they wanted the answer in the form of a plus bi, so that's my answer here. But that's in the form of a plus bi all divided by c. Okay, something else. To put it in this form, they say a and b can be real numbers. It means it can be fractions. Okay, it can be any number. So if I need to get that situation, when I need to have a as its own number and bi as its own number. So to do that, I divide the 26 into both sides. Now 26 and 17 plus 19i over 26, and that's in the form of a is 17 over 26 plus bi. The bi is 19i over 6, or sorry, 26. Small thing, but still with a mark, okay? And in a sense, we often get annoyed or confused by these particular little sections here, and they can be very off-putting, but usually they mean something very simple, although it again can be very off-putting. I think we're finished now with question 2. Yeah, so that's it, okay? So thanks very much for listening, and have a good day.